All right, hello, ladies and gentlemen of Algebra 2. We're looking at Unit 3, Part 2, solving systems of equations with three variables. Three variables has some of its own challenges, but kind of the basic concept is the same. You're kind of living in elimination, and towards the end, I'll show you a new trick using matrices that can kind of help you too. Elimination is going to be kind of my method of attacking when I'm solving. So let's take a look. Krista and Arthur both need pens and blank CDs. The equation that represents Krista's purchases is y equals 27 minus 3x. The equation that represents Arthur's purchases is y equals 17 minus x. X is the price of pens, y is the price of CDs. What are the prices of each? So you've got y equals 27 minus 3x, and you've got y equals 17 minus x. So if they're both equal to y, that means they're equal to each other. So what I'm going to do is say, you know what, 27 minus 3x, you're going to be equal to 17 minus x. Because they're both the same. I mean, the price, y represents the price of the CDs, and you know the CD doesn't change by person. So they're the same for Krista that they are for Arthur. So that's going to be equal to each other. So now it's just old school algebra, you know, doing the opposite of what's there. So add 3x, subtract 17, that's 0, that's 0. 10 equals 2x, so x equals 5. Okay, so x equals 5, that means that the pens are $5. So y then is going to be 17 minus 5, so that's going to be $12. So the CDs are 12, the pens are 5, there's my answer. So just setting them equal to each other. So now let's take a look here. 2004 Summer Olympic Games in Athens, Greece. The United States won 103 medals. They won 6 more gold medals and bronze and 10 more silver medals and bronze. Write a system of equations that can be used to determine how many of each type of medal they won. So G is gold, S is silver, B is bronze. So, and here's kind of how I want to do that. The first thing I want to say is, you know what, G plus S plus B equals 103. 103 is all the medals that they won. They won 6 more gold medals than bronze. Okay, so if bronze is going to be G plus 6. And they won 10 more silver medals than bronze. So B is also going to be equal to S plus 10. So there's my 3 equations. Okay, so now that would be, so this is the total number of medals. This is the relationship of bronze to gold. This is the relationship of bronze to silver. 6 more gold medals than bronze and 10 more silver medals than bronze. So if I'm going to solve this thing, like I said before, I want to live in elimination. But before I do that, I want to try and whittle this down to make my life easier. So here's kind of what I'm looking at. I'm going to take these first two. And I want to eliminate one of these variables. Okay, I want to eliminate one of these variables. And so and then I'm going to try and pick another 2. So I'm going to go these 2 together. And you know what I might do? I might just eliminate x just because that's out front. So I want to multiply this first one by a negative 2. So I'll rewrite it down here. So it'll be a negative 2x minus 4y minus 2z equals negative 20. So then when I add these two things, that goes away. I have negative 5y plus z equals negative 25. All right, so now what I want to do, that's one equation. So now what I want to do is pick 2 other equations, get rid of x again, and then now I've got 2 that I can solve. So if I look, if I take those 2, so let me write those over here. 2x minus y plus 3z equals negative 5. 2x minus 3y minus 5z equals 27. So what I want to do is I'm just going to multiply this bottom one by negative 1. So I'll leave the top one the same. And remember, big goal is I'm trying to get rid of one of the variables so that it's down to a system that I can work with. So when I put this together, 2x minus 2x goes away. 2y plus 8z equals negative 32. So now I've got two equations here. So I've got negative 5y plus z equals negative 25. And I've got 2y plus 8z equals negative 32. Now I can work with this. And what I kind of want to do is I want to keep going with this elimination. I'm going to multiply this times a negative 8. When I do that, this becomes 40y. This becomes negative 8z. This becomes positive 200. So now I'm going to add these two things. So I'm going to be left with 42y. The z's are going to go away. 200 minus 32 is going to be 168. So y is going to equal 4. Okay, so y equals 4. Now let's go back and figure out what z is going to be. Okay, so y equals 4. So if I go negative 5 times 4 plus z, that equals negative 25. So that's negative 20 plus z equals negative 25. So add 20. So z is going to equal negative 5. All right, so now I'm on my way. I got 2 out of the 3. I've got y equals 4. Y equals 4. Z equals negative 5. So now what I want is to go back, figure out what x is. So that's my last piece. What I'm going to do is this. So y equals 4, and z equals negative 5, pretty sure. Z equals negative 5, y equals 4. Okay. So that means I'm going to have, if I take this statement, I'm going to have x plus 2 times 4 plus a negative 5 equals 10. So this becomes x plus 8 minus 5 equals 10. So that means x equals 7. So that means final answer here, x equals 7, y, z equals 5, z equals negative 5, sorry, and y equals 4. There's my answer. So that's a lot of elimination going on here. So if I do kind of that same thing, here's what I want to do. 3x plus y plus z equals 0. Negative x plus 2y minus 2z equals negative 3. 4x minus y minus 3z equals 9. So for this one, a couple different ways you can go. I might look at eliminating y, and here's where I might start. I might start with the top and the bottom one, and I do this for this reason, because 3x plus y plus z equals 0, 4x minus y minus 3z equals 9. Those have already got the same, same thing in front of y's. That'll naturally go away, so I'll be left with 7x minus 2z equals 9. So I'm going to start with that. Then what I might do is this. I might say, let's go here. I might say, you know what? Let me go with this one and this one. Let me go with that second and third one. And I'll say, but I'm going to double that bottom one. So if I double this, 8x minus 2y minus 6z equals 18. So then I'm going to add the top one here. So I'm going to get 7x minus 8z equals 15. So now I've got these two together, okay? So what I'm going to do is bring this over. 7x minus 8z equals 15. Well, this makes life a little bit easier because all I got to do is multiply one of these by -1. So I'll leave the top one alone. Negative 7x plus 8z equals negative 15. So if I put that together, that's going to give me 6z equals negative 6. So z equals -1. So now if I throw this back in here, that's 7x minus 2 times -1 equals 9. So that's 7x plus 2 equals 9. So 7x equals 7. So x equals 1. So x is 1, z is -1. So to go back and figure out y, x is 1, z is -1. So that's 4 times 1 minus y minus 3 times -1 equals 9. So if I bring this over, let me work it this way. So that's going to be 4 minus y plus 3 equals 9. Negative y plus 7 equals 9. And I'll keep working out this way. Negative y equals 2, so y equals -2. So my final answer becomes x is 1, y is -2, and z is going to be -1. There's my solution. All right, so let's pause for a second here. Before I kind of get after this, what I might consider doing is I might consider trying to simplify here. Like this one, I can divide everything by 2. This one, I can divide everything by 3. That might help me simplify things, and I can totally do that. So I could have, divide everything by 2, so that'd be 2x minus 3y plus 2z equals 6. And I might go 2x minus 3y plus 2z equals 6. So then, if you notice something, these automatically match up. So when I do that, if I eliminated those two, I get 0 equals 0. So if I just subtracted those two, I would get 0 equals 0. That's always true. That's my dead giveaway that it's infinitely many solutions. So before I do anything, I'm going to look and see, can I eliminate one of those to make my life easier, basically, because it's a lot easier dealing with this than it is with this. All right, so let's take a look here. So if I think I can divide everything by 2 there. 3x plus 6y minus 4z equals 12. This one, I want to say 3, so that would be 3x plus 6y minus 4c. I'm pretty sure that's supposed to be a z. Let's pretend it's a z. So if I divide everything by 3, that equals 10. But now take a look here, guys. See, if I subtract these two things, I end up with 0, 0, 0 equals 2. Is that ever true? Absolutely not. That's going to be false. And again, all this stemmed from, can I find a greatest common factor for those top two? Just to see if my life can be simpler before I even try and attack this problem. So when I figured that out, I subtracted the two. I noticed I get 0 equals 2. That's going to be false. That's my tip-off that it's no solution. Okay, so that's going to be my... All right, so for this one, you have x plus y plus z equals 20. The second number is 4 times the first. So 4x, 4 times the first equals the second. Sum of the first and third is 8. All right, so here's what I'm going to do. I'm going to do a couple things. One, I am going to swap 4x in there for y. And then I'm going to do a little algebra on the second one and say, you know what, z equals negative x plus 8. So that's going to be rewritten. I'm going to rewrite it over here. I'll do it in a different color. That's going to be x plus 4x. Sorry, that's an x. Just only looks like a z. Plus negative x plus 8 all equals 20. So if I put this together, this is going to be 4x plus 8, all equals 20. So 4x will equal 12. So x is going to equal 3. So if x equals 3, let's work backwards here. X equals 3. So y is going to be 4 times 3. So that's going to be 12. And then z is going to be negative 3 plus 8. So that's going to be positive 5. So my answer here is going to be 12, 5, and 3. All right, so there's 49,000 seats in a sports stadium. They sell for $25. Middle are 30, bottom are 35. Number of seats in the middle and bottom equals the number of seats in the upper level. All of the seats are sold for an event. The total revenue is $1,419,500. How many seats are there on each level? So if we go upper plus middle plus lower, it equals 49,000. All right, the total number of seats in the middle and bottom, or the middle and lower, let's do that. We'll call this, instead of lower, we'll just call it bottom. So the middle and the bottom together equals the upper. So upper equals M plus B. And when all the seats are sold out for an event, it's $1 million, $1,419,000 and $500. So 25U plus 30 middle plus 35B equals 1,419, 500. All right, so here's kind of my system. And here's what I'm going to do. I'm going to kind of rewrite this. U plus M plus B equals 49,000. And then I'm going to move all this over to the other side. So U minus M minus B equals 0. 25U plus 30M plus 35B equals 1,419,500. And I did this for a reason. I mean, another way to do it would be to throw this into here and throw it into here, so you're left with just M and B, and then go from there. What I'm going to do is this. I set this up for a reason. What I'm going to do is use a matrix, and here's kind of what it's going to look like. I'm going to take just the coefficients, just the numbers, and the way that this is going to set up is like this. Okay, so just the coefficients times just the variable equals that. All my answers. So now what I'm going to do is I'm going to put this into, oh, this is getting tricky. What I'm going to do is put this into a matrix equation. So what I'm going to say is UMB is going to be equal to that first matrix times the inverse. Okay, I'm going to take the inverse of that first matrix, because it's like I moved it over to the other side, and then go 49,000, 0, 149, 500. I'm going to multiply those two. So what happens when I do that? Well, I'm going to do it in my calculator, and if you really want me to show you, I can show you. But here's what's going to happen. So when I throw all that in a calculator, I let the calculator do like all the legwork for me. All right, I put it into matrix, and what I get is an answer of this, and it comes out as a matrix: 24,500, 10,100, 14,400. And that is my answer, ladies and gentlemen. Okay, this is my upper, my middle, and my bottom. That's how many seats there are. Okay, so that's going to be my answer right there: 24,500, 10,100, 14,400. All right, if you want me to, I can show you tricks on how to do that on a calculator. It doesn't take very long. It takes a little bit of practice, though. All right, Mike knows he scored a total of 70 points so far this basketball season. His coach told him that he scored 37 times. Mike wants to know how many free throws, field goals, and three-pointers he has made. The sum of his field goals and three-pointers equals twice the number of free throws minus 2. How many free throws, field goals, and three-pointers has Mike made? You know what? Show me that problem out of your notes. I want to see you do this and then show it to me out of your notes. And if you still need my help, I will be glad to walk through it, but I want to see you guys do it and at least check this setup. Come talk to me with problems, then I'll give you your assignment.